Okay, last page. The name of the game here is no radicals in the denominator. Okay, which is the bottom part of our fraction. And a radical is a square root that doesn't simplify. So when I'm doing this, there are a variety of different techniques, but first I'm going to look at, does both the top and the bottom have a radical, or is it just one or just the other? Here I have an entire fraction inside that I see both 8 and 14 can simplify by 2, so I'm going to make that 4 over 7. I like dealing with smaller numbers, so if I can simplify because they're both inside the radical, I'm going to do that first. You don't have to, it just makes the number smaller. Now, because you're square rooting both top and bottom, we can think of it as the square root of each top and bottom individually. Square root of 4 is 2. Square root of 7 doesn't simplify. So I'm going to have to multiply by something, top and bottom, that will make this a perfect square on the bottom. Square root of 7 will do that because this gives me the square root of 49, which is 7. 2 times square root of 7, one number stays outside and multiplies out front because they're not like terms. And, well, yeah, one's inside and one's out. And then this goes over 7. I can't reduce 2 and 7, so I'm just going to leave it like that. Okay. Part B, 3 over square root of 8. Now, I could simplify square root of 8, or I could just multiply by something that would make this a perfect square. So my perfect squares are 0, 1, 4, 9, 25. Oops, I skipped one. 16, 25. Now, I can multiply 8 by something to get that. So I'm going to do square root of 2 times square root of 2, because that gives me square root of 16, which is 4. My numerator becomes 3 square root 2 over 4, and that is the most simplified version. If you didn't think of that and you decided to multiply by square root of 8, that's fine. It's just not going to be simplified. That gives you square root 64, which is 8. But that is technically 2 root 2. So it's 3 times 2 root 2 over 8. And then it can simplify further because, 2 and 8 can reduce to give us 1 and 4. And then we're back to our original answer. All right, for C, we have to multiply by the conjugate. Okay, the conjugate means I'm going to keep the 7 and the square root 5 the same. All I'm going to do is I'm going to change the sign that's between them. So I'm going to put a minus sign between them instead of a positive. That helps me because we get, 63 up top minus 9 root 5. If I do the plus and minus, remember, a squared minus b squared. If I factor that, then we get a plus b and a minus b. So I end up losing the middle terms of positive ab and negative ab if I multiply, by foiling. They cancel out. So that's why I get 7 times 7 is 49, and that times that is negative square root 25. Which means this is 49 minus 5, which is 44. I can't simplify the numbers that are all outside the radical, so I'm just going to leave it like that. Okay, down here we have 12 over square root of 8 minus 3. Now again, my conjugate means I keep everything the same except for the sign between. So I'm going to change that to a positive this time. All right, so now when we distribute the 12, we get 12 root 8 plus 36. This becomes square root 64, which is 8. And this is now minus 9. So 8 minus 9 is negative 1. I can divide that out and get negative 12 root 8 minus 36. Okay, technically that is a correct answer. However, this we learned up earlier is 2 square root 2. So negative 12 times 2 square root 2 minus 36, I can multiply the numbers on the outside to get negative 24 square root 2 minus 36. And that's going to be my final answer. Let me know if you need help with any of these or if you want to talk on Zoom.